Hi everyone, Mr. Kranz here, and this will be Geometry Lesson 2.6. What we're going to do today is we are going to start looking at properties of equality and applying it to proofs. Now, what we're going to really do with the stuff that we've learned already, logic and reasoning, is we're going to use these skills of logic and reasoning to prove some different mathematical equations and properties. Let's go ahead and get started. All right, properties of equality. So the addition property of equality. This basically states that if A equals B, then A plus C equals B plus C. I like to break this down a little differently. Let's say that A plus C is going to equal C plus B. Remember that law of syllogism where you take the middle and you cut it out? Well, look what's left. A equals B. So you see how that kind of relates? We can also do this mathematically, saying that, well, if 3 plus 2, well, that has to equal, let's say, well, technically 3 plus 2, which is what's written here. Well, if this is A, and this is C, and this is B, and this is C, see how A and B have to be the same? So that's kind of what it's saying. That's the law of equality. Addition property of equality. Now, subtraction property of equality. That's saying that, well, if A minus C equals B minus C, then A and B have to be the same, have to be equal. See how it's the same property? I mean, think about it. If I rewrote this as, you can't rewrite this as C minus B in this case because subtraction isn't commutative, meaning you can't move stuff around. But, if this was, let's say that this is 3 minus 2, which equals 1. Well, if we know that C is 2, then this has to be 3. That's why A and B are equal. So that's the property of equality. Multiplication property of equality. Well, A equals B, then A times C equals B times C, making A and B the same. Let's look at it mathematically. 3, keep doing that. 3 times 2 is 6. Well, we know that C is 2, so that has to be a 3, right, to make it equal to 6, so why A and B are equal. Division property of equality. If A divided by C equals B divided by C, then A equals B. Right? So basically what we can see is that if we were to go ahead and cross multiply this, A times C would equal AC, and C times B would equal BC. If I divide by C, those go away. If I divide by C, those go away, which just leaves me A equals B. Distributive property, if A times B plus C, then A times B plus C equals AB plus AC. That's just distribution. Learn that in algebra. A times B, A times C equals that. Substitution property. If A equals B, then A may be replaced by B in any expression or equation. So if two things are equal to each other, they can be interchanged whenever you want. Reflexive property. For any real number, A equals A. Reflexive property, think of it like a reflection. That's a mirror image of itself, so it's the same. Symmetric property. If A equals B, well, guess what? B equals A. It's symmetry, like a mirror. See, if there was a mirror image of itself, it would flip over. That's called a reflection. Transitive property. If A equals B and B equals C, well, guess what? A is going to equal C. That's that syllogism again, right? Same thing I showed up here. You can cancel these middle ones out, and A equals C. So using the properties of equality. Properties of equality can be used to justify steps in solving an equation. So here's our new thing we're going to do is something called a two-column proof. One of the hardest things you're going to work on in geometry. And we're going to practice it a lot. And as we go through it, you'll get a little better because in the end, a lot of these proofs are very similar. So two-column proof, a common format used to organize a proof. The left side is a list of the statements or steps, and the right side is a list of the reasons that justify each step. So what can be used as reasons? Properties, definitions, postulates, and theorems. So we're going to see how this works. Right now it seems a little abstract because we're not seeing it. Now you have your note guide, so you're going to fill this in. I kind of feel like right now my handwriting is so poor, especially writing on a tablet, but it's even worse when I write on the board. I just, can't help it. So I have this kind of pre-written, so you should be filling this in. And let's kind of talk about what's happening here. It gives us something called, a given, some information that we're going to start with. And then it gives us something that it wants us to prove. Now, the way this works is that we have something called statements. This is going to be like our roadmap to solving something. Now, notice that this and this are the same, right? We always start off with our givens, and our final statement is what we're trying to prove. So let's go ahead and check this out and see how this works. Now, I have written here 4x minus 1 equals 27. How did we know that? Well, we know it because it gave it to us right here in this given. So our reason is given. Now, 4x equals 28. How do we know that? Well, we know that if we go 4x minus 1 equals 27, right, and we add 1 to both sides, these cancel out, giving us 4x equals 28. Everyone should be agreeing with that. That has a name. That name is the addition property, right? We added something to one side. Now, how is x equals 7? Well, x equals 7 because we went ahead, and we divided by 4 on both sides, giving me x equals 7. Well, what did we do here? We divided, correct? So when we divide, that's the division property. And now you've gone ahead and you've proved that x equals 7, given that 4x minus 1 equals 27. Your proof is complete. It makes sense. Basically, if you don't remember what the name of the rule you're using is, think about what you did. Didn't I add something to this side? So that's where the addition property. Here I divided by 4, so that's the division property. Right, so number 2. A over negative 6 plus 2 equals 5. That's our given. Notice that our given is clearly written here. That is our given. We need to prove that A equals negative 18. Now, in all honesty, these statements, which are on the left side, are being provided for you. They will not always be provided. You're going to have to do them yourself at some point. All right, so let's go ahead. How did we get from here to here? Now, when you think about it, what's missing? You see how this 2 is missing? How did this 2 move over here and become 3? Well, see how we subtracted 2? So that would be the property of subtraction. It's the subtractive property, right? Subtraction property. Now, how do we get this 6 out of here? Well, since A is being divided by negative 6 and that equals 3, we undo division with multiplication. So we're going to multiply both sides by a negative 6, canceling that out and giving us A equals negative 18. Since we multiplied, this will be the multiplication property. And now we're done. See how this matches this now? That is our final step. Let's go ahead to our next one. We have negative 9 times 2x minus 3 equals 63. That's our given. So that's our first statement is our given. We need to get it where x equals negative 2. So what is this called when we do this? What do you do when you have parentheses? It's called distributing, right? Negative 9 times 2x is negative 18x. Negative 3 times negative 9 is positive 27. So that is the distributive property. So now we notice that this 27 has disappeared, and this became 36. Well, obviously we're minusing 27 here. Right? So we're going to go ahead and we're going to minus 27. So that is called the subtraction property. And then finally, what are we doing with this negative 18x? We're going to divide by negative 18. When we do that, we get negative 2 on this side, so this will be the division property. So see how we're going along the same steps over and over here? All right, now we have number 4 and number 5. Number 1 says 6x plus 7 equals 8x minus 17. That is our given, and we're trying to prove that x equals 12. Where is the difference here? Notice this has a 6x on this side, and this does not. Well, what happened? The 6x was subtracted to this side, the right side, making it 2x. So that would be the subtraction property. Now, when we look over here, we notice that this negative 17 is gone and it's moved to this side on the left. Well, when it moved to the left side, what winds up happening is that it is added to 7. So that is the addition property. Finally, we divided by 2, right? And we got x equals 12. 12 equals x, excuse me. That over there. That's the division property. Now, notice, technically, this here does equal this, but it wants us to do this. And how does that happen? Well, we're just going to flip it around the other way, and that's symmetry. Symmetric property, because remember, we have this 12 equals x, right, is x equals 12. That's that symmetry. All right. Number 5. Why don't you go ahead and pause me, see if you come up with the same answers I do. All right. So, we are given 7 times x, negative 7 times x plus 2 plus 4x equals 6 times 2x minus 4, and we need to prove that x is equal to 1.5. We have our given. Now notice down here, all of our parentheses have been removed. How do we remove our parentheses? We distribute. So that'll be the distributive property. Now, what has changed over here? Here we had negative 7x minus 14 plus 4x. Here we had 12x minus 24. Notice that our negative 7x and our 4x are missing. And what has happened to them? Well, all we're doing is combining like terms, right? We've taken our negative 7x and our positive 4x, and it's become a negative 3x. Now, you could say this is called, we simplified it, or we combined like terms, or CLT, which is fine with me. All right, now excellent. Now, see how we had a negative 3x here to 12x here? Now we have a negative 15x, like this 12x was subtracted to this side. Well, subtraction, that's the subtraction property. Then, finally, we see that this 14, what happened to that? Well, it got added to this negative 24 and got us a negative 10. So that's the addition property. And finally, we divided by negative 15. So that's the division property. All right. So what we're going to do now is we're going to go on to some practice. And you're going to notice next is your statements are missing. So now you have to do the statements yourself. What was the first thing I said you should always write on that first line? Yes, you should write the given. So I go ahead and I wrote the given. And the reason it's there is it's given. Now, all you're going to do for these is you're not going to overcomplicate them. I suggest working on the statements first here. Do algebra, right? You're going to subtract 1, giving you 3x equals negative 15. What do you do next? You divide by 3. X equals 5, negative 5, which is where we need to be. How do we get here? We subtracted 1, subtraction property. We then divided by 3. That's the division property. And we are finished. Go ahead and try number 2. Go ahead and pause me. All right, first thing we're going to do is we are going to write our given statement and write given. Now, what happened next? Well, obviously we want to get rid of these parentheses, so we're going to distribute this, right? So that would be the distributive property. Now, we're going to go ahead and add this 18 to the right side, which is the addition property. And finally, we're going to divide by 2, which is the division property. All right, let's go ahead and look at number 3. First, we're going to do our given, which is right there. Now, what's the first step here? We want to get that m by itself, so this 10 is in the way, so we're going to subtract a 10, giving us m divided by negative 3 equals negative 11, which is that subtractive property. Now, how do we get that 3 out of the denominator? We have to multiply by negative 3 on both sides. Right? So we multiply by negative 3, cancels out the 3. We go ahead, and that is the multiplication property. And guess what? We are completed because we have m equals 33. Once again, number 4, you're going to write down your given with the reason given. So the problem with this one is that the 2 is hanging out in the denominator again. So we're going to multiply by 2 on both sides, giving us 5y minus 1 equals 14. That's the multiplication property. We're then going to add 1 to both sides. That's the addition property. Then we divide by 5, which gives us y equals 3. All right, so now in your note guide, why don't you finish this up and go through 5 through 8 by yourself, and I will go ahead to the next slide and start doing them. All right, so for number 5, we're going to write our given. We notice that we have variables on both sides, constants on both sides. So we're going to go ahead and move over our 2k. So we subtracted. We then added 4 to the right side, which gives us the addition property. And then finally, we divided by 8, which gave us k equals negative 2. So that's the division property. Number 6, we're going to write down our given. Notice that we have variables on both sides. You're going to subtract a 5n, giving us negative 42 equals 7n. So that's the subtraction property. We then divide by 7 on both sides. That is the division property. And finally, we're going to use the symmetric property just to flip it over the other way so it looks the same as what it's asking for. Number 7, we're going to write down our given statement. Notice we have parentheses. To clear those parentheses, we are going to distribute. We went ahead and distribute, right? Negative 8w minus 8 equals negative 5w minus 50. What do we do next? Well, we're going to gather our constants on one side. If it was me, let's see what it does. I would add 8w to both sides, which it did not. So this one wound up taking and added 5w to this side. I would have went the other way, but either way, since it added 5w, still the addition property, it's going to subtract, add 8 to both sides, making an addition property, and divide by negative 3w, which is 14, division property. Once again, write this whole statement down with the given. First thing, clear those parentheses, which means that we are going to distribute. Remember, when we do this negative sign here, it becomes a positive 3x. Negative 3x, positive 34. Next thing, combine our like terms. These go together. The x's, the constants, they all go together. So that's simplify or combine like terms. Next thing we're going to do is we are going to gather our x's on the same side. We subtracted 2x here. So we're going to subtract subtraction property. Next, we're going to add 2 to the right side, which gives us 36. And finally, we'll divide by negative 4, which gives us x equals negative 9. I know it's a lot, these proofs, but you notice that if you do the left side and the reasons statements first, and you do it like you would normally solving algebra, it's very easy to write down what you did afterwards.